Welcome to The Simulation. The following podcast is based on cutting-edge research from leading organizations worldwide. It is brought to you by thelifesim.com, my new startup with the mission of building an immersive life simulator with worlds generated on demand. This conversation is voiced over by Jack and Jill, two AI voices I really enjoy. If you want to follow along and dive deeper into the research, the resources are always in the description down below. I hope you will learn as much as I did from this conversation, and if you want to be kept up to date with the most cutting-edge research about building the simulation, subscribe to this channel. I hope you will enjoy the following conversation and see you on the other side.
All right, so get this. What if you could play Doom, but like instead of code, it was all powered by AI. We're talking like a neural network, actually acting as the game engine.
Yeah, that's pretty much the gist of this paper we're looking at. It's called GameNGen.
And it's by, let me see, Danny Valevsky, Yaniv Leviathan, Moab Arar, and Shlomi Futre.
From Google Research, Tel Aviv University, and Google DeepMind.
Quite the team. Yeah. And they really might just totally change how we think about not just games, but like all interactive software.
Yeah, for sure. I mean, it really flips the script on how we think about making games.
Okay, so before we go too deep into the AI stuff,
Sure.
Remind me, how does a normal game engine work?
Okay, so you can think of it as this, like big loop with three main steps. So first, you have the player's input, like, pressing keys, moving the mouse, all that. And then second, the game engine uses its rules to update the game state based on that input. And then finally, it renders the next frame of what you see on the screen. And this loop just repeats super fast to create the illusion of, like seamless movement and interaction.
So game engine, they're basically skipping that whole rule writing process and going straight to AI.
Yeah, that's right. So GameNGen uses a neural network to basically learn how the game should look and behave. It's trained to predict what the next frame on your screen will be, given like the previous frames and your current actions.
Whoa, that's pretty mind-boggling.
Yeah.
So how do they even train an AI to do that?
Right.
You just like feed it hours of Doom gameplay.
It's a two-phase process. First, they create an AI agent that learns to play Doom, but and this is where it gets interesting. The goal isn't to be like a super skilled player. Instead, they gave it a reward system that encourages exploration, picking up items, even just smooth movement.
Huh. That's really different. I mean, in most game AI, you reward things like killing enemies or completing levels. Right. So why did the folks
It's exploring. Well, they needed the agent to produce diverse and interesting gameplay to use as training data. For GameNGen,
I see.
Like the goal wasn't to create
a
champion Doom player. It was to generate this like rich tapestry of actions and reactions that the game engine could learn from.
Okay, that's really interesting.
Yeah, and it kind of highlights a crucial aspect of AI development in general, which is the quality of your training data is really, really important.
So it's almost like they're not just teaching the AI to play. They're teaching it to teach another AI.
Yeah, you could put it that way. The first AI, the agent, is gathering the raw material. That will then be used to train the second AI, the game engine itself.
Okay, so phase one, the AI is playing Doom. What about phase two?
Right.
How do they actually create the game engine?
So this is where things get a little more technical. They use what's called a diffusion model. It's kind of similar to the technology behind image-generating AIs, like Stable Diffusion.
Okay.
But instead of creating images, it's predicting game frames. So the diffusion model learns from the recorded gameplay of the AI agent and figures out how the screen should change based on what the player is doing.
So it's not just
like
replaying the exact same gameplay that the AI agent did.
No.
It can actually handle new situations.
It's actually
actions.
Yeah. It's able to generalize from the training data and respond dynamically to new inputs. But this type of frame-by-frame generation presents a big challenge. It's what they call drift.
Drift.
Yeah. What is that? Okay, so imagine you're drawing a long line, freehand, but each segment is like based slightly off one before it end up way off target. It's kind of similar with generating game frames in sequence. These small errors accumulate and lead to these increasingly noticeable glitches and inconsistencies.
I see how that would be a problem.
Yeah.
So they solved it.
Their solution is surprisingly simple. Noise augmentation.
Okay.
They intentionally introduce a bit of randomness. During training, this forces the model to become more robust, to slight errors. You can think of it like practicing a skill, but with distractions, so you're better prepared for the unexpected in a real-world scenario.
Clever. But okay. How well does this actually work? Can you actually play Doom powered by this AI game engine?
Well, the results are actually pretty impressive. They measured the visual quality using a metric called PSNR.
Okay.
And GameNGen achieves scores that are comparable to standard JPEG compression. So in practical terms, you wouldn't be able to tell the difference between the simulated Doom and the original game for short clips.
Wow. So visually, it's pretty much spot on. What about the performance? Can it keep up with like the fast pace of Doom?
So on a single TPU, that's a specialized AI processing chip. It can run at a playable 20 frames per second. And with a few optimizations, they can boost that to 50 frames per second.
That's wild. Did they actually have real people test this out?
Yeah, they did. They ran a blind test where players had to try and distinguish between GameNGen's output and actual Doom gameplay. And guess what? They were barely better than random chance at telling the difference.
No way. That's really impressive.
Yeah.
So you mentioned that they trained the game engine on gameplay from that first AI agent.
Right.
Did they ever try training it on something else?
Yeah, that's a good question. They actually did experiment with a different approach. They wanted to see what would happen if they trained the game engine on completely random gameplay data, essentially skipping the step of having an AI agent learn the game first.
So it does just pure button mashing chaos.
Pretty much.
You'd think that would be a disaster.
You would think so, right? But the results were surprisingly decent, at least for simpler scenarios.
Really?
So the randomly trained model could still render the game world and handle basic interactions.
Wow. But I'm guessing there were limitations to this approach.
Oh, yeah, for sure. The limitations became very apparent when they tested both models on more complex gameplay situations.
Okay.
So the model trained on the AI agent's gameplay consistently outperformed the randomly trained one it was better at, rendering detailed environments, keeping track of the game's state, and just generally maintaining fidelity to the original Doom.
Yeah, I mean, the agent-trained model had a much better teacher, so to speak.
Exactly.
Like from gameplay, that was the more nuanced and strategic, which, you know, translated into a more accurate and robust game engine.
Yeah.
But it makes you wonder, is the improvement from the agent-trained model worth the extra effort? Like, wouldn't training on random gameplay be much faster and cheaper?
That's a question the researchers grapple with as well, they acknowledge. That training on random data has its benefits, especially in terms of speed and efficiency. But their findings suggest that as these models evolve and become more complex, the quality of the training data will become increasingly important.
So if we want AI game engines that can handle really intricate and aversive games, we're going to need to find ways to generate even better training data.
Exactly. Well, that's where the research is heading next. They're exploring ways to train AI agents to be even better teachers for these game engines, they believe. Techniques like reinforcement learning could create agents that can explore game worlds in more intelligent and creative ways, producing even richer training data.
This is also fascinating. I feel like we've only just scratched the surface here of what's possible with this technology. I mean, we've talked a lot about the technical details, but I'm really interested in the bigger picture. What does this mean for the future of gaming? Could AI really revolutionize the way we create and experience games?
I think. Absolutely. And that's where things get really exciting. Let's dive into those possibilities next. Imagine like game developers working with AI instead of, you know, spending all that time coding every detail. They could guide an AI agent through a game world, teaching it the rules, through example.
No more. Debugging endless lines of code.
Yeah, it could really change the development process. Like imagine creating these huge, intricate game worlds with the help of AI that can learn and adapt.
That's pretty wild.
Yeah, and you could iterate on designs way faster, you know, experimenting with different ideas.
Would that take away some of the creative control for the human designers?
Yeah. I mean, that's a really important question. Right. And it's something that developers are going to have to think carefully about.
Yeah.
But I see it as an opportunity to, like, push the boundaries of creativity even further. Like, AI could become this powerful tool for exploring new ideas and pushing the limits. What's possible in game design.
It could even, like, level the playing field, make game development more accessible to people who maybe don't have the technical expertise to code everything from scratch.
It could open up a whole new world of possibilities for indie developers, hobbyists, even kids.
That's a good point. What about the players, though?
Yeah.
How could this change how we actually experience games?
Well, think about, like, personalization, you know? AI could learn your play style, your preferences, and tailor the game experience to you.
So, like, the game adapts to how I play.
Exactly.
That's cool.
It could solve the problem of games being too easy or too hard. It could keep you constantly challenged.
What about that memory issue we were talking about earlier? Only 3 seconds of gameplay history.
Yeah, you're right. That is a significant limitation.
It seems like a major roadblock to, like, creating really immersive and complex AI-powered games.
Yeah, the paper actually includes some visualizations that demonstrate the problem, and you can see how the output starts to drift over time, especially in scenes with
like rapid movement or
intricate interactions.
So it's like the AI is forgetting what just happened.
Yeah, basically.
And the game world starts to lose its consistency.
Yeah.
So is there any way to fix this? Can they give GameNGen a better memory?
So the researchers are actively exploring ways to improve the model's memory capacity. One promising approach is to incorporate something called attention mechanisms.
Attention mechanisms, what are those?
Okay, so think about how our own brains work. We don't remember every single detail of everything we experience. Instead, we selectively focus on the most relevant information.
I see.
Attention mechanisms kind of work in a similar way. They allow the AI to prioritize which pass frames are most important for predicting the next frame.
So it's like it learns to pay attention to the important stuff.
Exactly. It's a way to make more efficient use of the limited memory capacity. Another idea they're investigating is to use a recurrent neural network, or RNN.
I've heard of those for like language processing.
Yeah.
They're good at handling sequences of data.
Right. Like words in a sentence that RNNs have, a kind of built-in memory that allows them to keep track of information over longer periods. So integrating an RNN into GameNGen's architecture could potentially give it a much larger window into the past.
Giving GameNGen a brain upgrade.
Yeah, you could say that. And they've even explored even more radical ideas, like adding external memory modules that could store vast amounts of information. It's like giving the AI access to an external hard drive.
Whoa, that's pretty sci-fi. But all these upgrades, I imagine they require a lot more computing power.
Oh, yeah.
For sure.
Which, can get expensive.
You've hit on a fundamental trade-off in AI research. It's about finding the right balance between model complexity and practical constraints.
Yeah, right.
They're optimistic that as hardware and software technologies continue to advance, we'll be able to overcome these hurdles.
Hopefully.
But they also acknowledge there's a lot of work to be done. I mean, this is still very early stage research. There are a lot of unknowns.
And that's what makes it so exciting. We're on the frontier of this whole new era of interactive software.
Absolutely.
And we're only just starting to glimpse the possibilities.
I agree. It's a thrilling time to be following this field and the implications extend far beyond just gaming.
Okay, I'm hooked. Let's talk about that. They mention in the paper that this technology can be applied to all sorts of interactive software.
Right.
But what does that actually mean? Give me some examples. Okay, let's start with something we all use every day, our smartphones.
Okay.
What if we could train a neural model to run parts of a phone's operating system?
Well, hold on. You're saying my phone could be powered by AI instead of traditional code?
Yeah.
What would that even look like?
Imagine like a neural model that manages your phone's battery life.
Okay.
It learns your usage patterns and dynamically adjusts settings to optimize power consumption.
So my phone would last longer on a single charge.
Exactly.
That's awesome.
It could also personalize your user interface, adapt the layout and features based on your habits and preferences.
So like we would learn how I use my phone and make it easier to use.
Exactly. It could even anticipate which apps you're likely to use next and preload them in the background.
Okay, now that's starting to sound pretty futuristic.
It's all about making everything feel faster and more seamless.
It would be less like a device and more like a personal assistant that knows what I want before I even know I want it.
Exactly. And the possibilities. extend far beyond smartphones.
Like what?
I mean, imagine applying this technology to...
Oh, self-driving cars, smart homes, even medical devices.
That's a lot to take in, but with all this AI, making decisions for us, wouldn't we be? Giving up some control.
I mean, yeah, that's
definitely.
A Bilal concern is crucial. As we develop these AI-powered systems, we prioritize transparency and user agency. We need to make sure that people understand how these systems work and have control over how their data is used.
So there's a lot to consider here, both the potential and the ethical challenges, it feels like. We're on the verge of something really transformative.
I agree.
But there's still a lot of unknowns.
That's the nature of cutting-edge research.
Right.
We're exploring uncharted territory. It's impossible to predict where it will lead us.
Yeah.
But the journey itself is fascinating.
I'm excited to see what the future holds.
We've covered a lot of ground today, from the technical details of GameNGen to the broader implications for gaming and beyond. But before we wrap things up, I want to leave our listeners with one final thought to ponder. So we talked about games and smartphones, but what if we took this concept of an AI-powered engine to something even more complex, the human brain?
Oh, wow. That's a fascinating thought.
I mean, we're already seeing AI being used to analyze brain scans and model neural activity. It's almost like we could create a digital twin of the brain, simulating its processes, and maybe even predicting how it might react to different stimuli.
It's a bold idea, but the possibilities are pretty amazing. Imagine using these models to study neurological disorders, personalize treatments, or even develop new therapies.
Could we one day have AI that helps us understand the brain in ways we never thought possible?
It's certainly a possibility, but it's important to remember that the brain is incredibly complex, and we still have a lot to learn.
For sure. So, bringing it back to the GameNGen research. What's next for the researchers?
Well, they're already working on several fronts to push this technology even further. One key area is improving the model's memory.
Right. Those 3 seconds of gameplay history.
Exactly.
What are some of the approaches they're exploring?
As we discussed, they're looking at ways to incorporate attention mechanisms, recurrent neural networks, and even external memory modules.
To give the AI a larger memory capacity.
Right.
What about making the model more versatile?
Yeah. So right now, GameNGen is primarily focused on visual output.
Predicting what the screen looks like.
Right. But they're exploring ways to expand its capabilities.
Yeah.
To include other sensory modalities.
Like what?
Things like audio and even haptics.
Yeah. But imagine an AI that could not only render the visuals, but also generate the sounds and even the physical sensations.
Exactly.
It would create a much more immersive experience.
Sure. And are they also trying to make the model more interactive? Yeah. They're experimenting with ways to allow users to influence the game.
So it's not just watching the AI play.
No.
It's about actually interacting with it.
Exactly. Shaping the experience, collaborating with the AI.
That's pretty wild.
It's about pushing the boundaries and redefining the relationship between humans and machines.
That's a big one.
Right.
So I'm guessing there are still some challenges ahead?
Oh, yeah, definitely.
What?
One of the biggest is computational complexity.
Right.
These models require a lot of processing power, which can be costly and energy intensive.
So they're trying to make the models more efficient.
Right. They're using techniques like model compression and knowledge distillation.
So it's about finding the right balance between power and practicality.
Exactly.
What about making sure that these systems are reliable?
Yeah, that's another big challenge.
Especially with Mary, that whole drift problem.
Right. They're working on ways to mitigate that.
It seems like there's still a lot of work to do. But it's amazing to see what they've accomplished so far.
It really is. This research has the potential to revolutionize how we interact with technology, from the games we play to the devices we use every single day.
Well, we've given our listeners a lot to think about today. Be sure to check out the GameNGen demo video. We'll include a link in the show notes. And again, we want to hear your thoughts. Could AI really change the face of interactive software?
Let us know in the comments. Until next time.
Happy diving.